GIS Fundamentals Section 7, Digital Data. Map services versus locally storable data. We must distinguish between data that are available for transfer to, storage on, and manipulation in a local computer, or locally storable, from those data that are available as web services, including web mapping service, feature web services, and web coverage services. There are many differences among web map services, web feature services, and web coverage services. But in broad strokes, a web map service is for serving cartographic data for producing and displaying maps, while web feature services are vector and web coverage services are primarily raster, and they deliver data and metadata in ways that ease spatial processing and analysis. Most data through services are currently provided as web mapping services, with a few systems supporting and using the editing and analysis functions available through web feature services and web coverage services. Web services save space on the local hard drive. A community of users may share the data. Many different kinds of data may be joined together more easily, as accessing web services typically requires a few mouse clicks. However, you may often not manipulate or change web mapping service data in any substantial way, and some kinds of analysis may not be supported or allowed. In these cases, local copies of the data are typically required, or web feature services or web coverage services are developed. Map services may also require a fast and reliable internet connection, particularly for high-resolution image data or other large raster datasets. National and global digital data. Global data are scarce because few governments collect spatial data in the same way or with the same set of attributes. Different governments specify different datums, standard map projections, data variables, and attributes, or have different requirements for survey accuracy or measurement units. NASA provides a large and diverse group of global spatial datasets. Global raster datasets available from NASA include elevation, land use, ecosystem type, and a number of measures of vegetation productivity, phenology, structure, and health. Given the substantial difficulties in compiling data from disparate global sources, the Global Spatial Data Infrastructure (GSDI) initiative was formed. The Global Spatial Data Infrastructure is an attempt to coordinate collection and processing methods worldwide to ensure that spatial data are broadly suitable for global level analysis. The Global Map is one early Global Spatial Data Infrastructure initiative. The Global Map specifies 8 thematic layers: boundaries, elevation, land cover, vegetation, transportation, population centers, and drainage. OpenStreetMap is one notable effort to develop global data through international volunteer collaboration. Much like Wikipedia, this is an open-access, user-generated resource. While OpenStreetMap provides the best data in many regions, there are potential drawbacks with these data. Because it is a collaborative, quality documentation and uniformity may be lacking. Currently, the data may be downloaded from the primary website in publicly defined but rarely used data formats. Global digital elevation data. Relatively high-resolution global digital elevation models are available from 3 sources. The oldest is the Shuttle Radar Topography Mission, SRTM. The second widespread global elevation dataset is based on the Aster satellite and uses image stereo pairs collected in the early to mid-2000s. The third source of global DEM data comes from a pair of satellites launched and operated by the German Aerospace Center and the European Aeronautic Defense and Space Company, EADS. Digital data for the United States. National Spatial Data Infrastructure. The United States has defined the National Spatial Data Infrastructure, NSDI, as the policies, technologies, and personnel required to ensure the efficient sharing and use of spatial data. The NGDC website, found at http://clearinghouse1.fgdc.gov, is perhaps the best current resource when searching for geospatial data for the United States. The U.S. Geological Survey, USGS, is the best single source of geospatial data from the U.S. federal government. The U.S. National Map. Digital data are available for most of the United States through the National Map project, described as a cornerstone of U.S. mapping efforts. Digital elevation models. Digital elevation models, DEMs, provide elevation data in a raster format and are available at 10 meter or better resolution for all states but Alaska. Ground and aerial surveys are the primary source of original elevation measurements for most DEMs. Aerial images and airborne LiDAR surveys complement field surveying by increasing the number and density of measured elevations. DEMs with 3, 10, and 30 meter horizontal sampling frequency are available for much of the United States. Currently, the USGS delivers these DEMs as part of the National Elevation Dataset, NED, through the National Map Portal. Hydrologic data. The National Hydrologic Dataset, NHD and NHD+, contains digital spatial data about surface waters, including rivers, streams, canals, ditches, lakes, ponds, springs, and wells. The NHD combines data from USGS, digital line graph data, and United States Environmental Protection Agency, EPA, river reach data. A reach is a segment of a stream, river, or coastline considered homogeneous under an EPA classification scheme. NHD data are organized by areas in a hierarchically nested set of hydrologic units identified by unique codes, HUCs. These units correspond to watersheds, or basins, or logical aggregations, or subareas of watersheds. The United States EPA also provides data on waters and watersheds of various types and formats, organized to correspond to the HUC data at some levels. There is an emerging system for storing, finding, and retrieving hydrologic data associated with the CUASHI project, CUASHI. The CUASHI is a National Science Foundation funded project involving more than 120 universities to support hydrologic science and education. Integrated, consistent, continent to worldwide hydrography data are also available from the Natural Earth Data Projects, www.naturalearthdata.com. Digital images. High-resolution digital image data are typically collected every 5 to 10 years by the USGS. The high-resolution orthophotographs, HROs, are among the highest resolution, widely available image datasets. The HRO images are collected and distributed through the USGS. Legacy aerial photographs, SCS, DOQ, NHAP, and NAPP photos. The oldest images are available from the United States National Archive and Records Administration, Cartographic and Architectural Branch. Digital orthophoto quadrangles, DOQs, produced in the late 1980s through 1990s, were the first set of widely available scanned photographic images. NAIP digital images. The National Aerial Imagery Program, NAIP, acquires photographs during the growing season in the continental United States. The National Aerial Imagery Program, NAIP, is primarily for one purpose: to monitor agricultural landscapes. National Land Cover Data. The National Land Cover Database, NCLD, is the most recent and detailed source of national land cover information. National Land Cover Database, NLCD, versions are produced in cooperative effort by a number of United States federal government agencies under the Multi-Resolution Land Characteristics Consortium, MRLC. So these are sometimes referred to as Multi-Resolution Land Characteristics Consortium, MRLC, data. NLCD data have been produced 4 times, known respectively as NLCD 1992, NLCD 2001, NLCD 2006, and NLCD 2011, corresponding to the primary data collection years. NLCD land cover classifications are based primarily on 30-meter Landsat thematic mapper data. NASSCDL. The National Agricultural Statistical Service, NASS, produces yearly crop data layer, CDL data. The National Wetlands Inventory. Data on the location and condition of wetlands are available for much of the United States through the National Wetlands Inventory (NWI) program. National Wetlands Inventory data are produced by the United States Fish and Wildlife Service. NWI data portray the extent and characteristics of wetlands, including open water, and are available for approximately 90% of the conterminous United States. About 60% of the conterminous United States is available in digital formats. Digital soils data. The Natural Resource Conservation Service, NRCS, of the United States Department of Agriculture has developed 3 digital soils datasets. The National Soil Geography (NATSGO) dataset is a highly generalized soils map for the continental United States. State Soil Geographic (StatsGO) data are intermediate in scale and resolution, and Soil Survey Geographic (SURGO) data provide the most spatial and categorical detail. SURGO data are intended for use by landowners, farmers, and planners at the large farm to county level. SURGO data are developed from a combination of field and photo-based measurements. SURGO data are linked to a Map Unit Interpretations Record, or MUIR. StatsGO digital soil maps are smaller scale and cover broader areas than SURGO soil data. StatsGO data are typically created by generalizing SURGO data. StatsGO data are developed via a redrafting of more detailed data onto 1 to 250,000 scale-based maps. Digital floodplain data. The Federal Emergency Management Agency, FEMA, develops and disseminates flood hazard maps, commonly known as floodplain maps. Climate, geology, and other environmental data. The National Climatic Data Center, NCDC, maintains historical climate records for the United States and provides their data through a web portal. Mineral resources data are available from the United States Geological Survey. Digital census data. The United States Census Bureau developed and maintains a database system to support the national census. This system is known as the Census Tiger System, or Topologically Integrated Geographic Encoding and Referencing. The Tiger System is used to organize areas by state, county, census tract, and other geographic units for data collection and reporting. Tiger line files are at the heart of the system. They define line, landmark, and polygon features in a topologically integrated fashion. Lines, called chains in the Tiger system, most often represent roads, hydrography, and political boundaries. Although railroads, power lines, and pipelines are also represented. Polygon features include census tabulation areas, such as census block groups and tracts, and area landmarks, such as parks and cemeteries. Point landmarks, such as schools and churches, may also be represented. Topological attributes are attached to the nodes and lines. Tiger line files contain information to identify street address labels. Many United States government datasets are provided with codes compatible to the United States Census Bureau data. The United States Department of Education, the United States Department of Transportation, and the United States Centers for Disease Control. Data from these organizations are delivered with codes needed to link statistics to geography. GIS Fundamentals, Section 7, Digital Data, Section Summary. Digital data are available from a number of sources and provide a means for rapidly and inexpensively populating a GIS database. Most of these data have been produced by government organizations and are available at little or no cost, often via the internet. Data for elevation, transportation, water resources, soils, population, land cover, and imagery are available and should be evaluated when creating and using a GIS.